Hello everyone, this is Ray Space in Realism Overhaul Sandbox in Kerbal Space Program 1.12. Recently I got a comment about the space shuttle reminding me that I should do shuttle things. I have a moratorium on Mercury, Gemini, and Apollo things. I really don't want to do any more Mercury, Gemini, and Apollo things. But the shuttle is actually underdone as far as things are concerned. When you think about it, Mercury, Gemini, and Apollo all combined had less than 30 crewed missions, whereas the shuttle had 135. So there's a lot to do with the shuttle, and even in terms of pushing the boundaries of technology, there is a lot to do with the shuttle, particularly because it was sort of ahead of its time. There are a few sort of limiting factors that have led me to not do shuttle things. First of all, everything takes a lot more time because its cargo capacity is limited. It's only got about 25 tons capacity to low Earth orbit, and so it's just easier to do things with like the Kasei rocket or any large rocket or, Starship, Super Heavy, and stuff like that. You have to do a lot of launches to put stuff together with the shuttle, and then you feel somewhat obligated, or I feel somewhat obligated, to actually bring the shuttle back down, and that takes extra time. So there's a time commitment to it. And also, if I'm going to be using the Giulio Dondi scripts to launch it and bring it back, I can't modify the shuttle the way I might want to, right? I mean, I have to use the shuttle as is, the regular shuttle with the regular engines and the regular boosters, or those things won't work. Well, the reentry will work without the regular boosters. We could have some other launch script, my own launch script, launch the shuttle, and then as long as the shuttle itself was largely unmodified, then the reentry script would work. But in any case, the prospects of modifying the shuttle are limited. And that is one other reason why I haven't done quite as much. As far as running through all the shuttle missions, that was another possibility, just going from STS-1 to STS-135. Of course, the disasters hold me back from that. Yeah. Anyway, so here we are, and I do have something to test. And in this case, it's a payload. That way I don't have to modify the rest of it. And what we want to do is find out if the shuttle had a ion engine upper stage to use instead of what it normally used, which was the inertial upper stage. That was another thing. In the comments, people talked about the shuttle using the Centaur stage. The shuttle never actually launched with the Centaur stage. That's a hydrogen-oxygen stage that has high performance but is sort of risky because it is hydrogen-oxygen, and also it was fairly large for the shuttle as far as the shuttle's payload capacity. So it was planned to use a modified Centaur stage meant for the shuttle, but it never actually did that. And that was because the Challenger accident happened, and they decided to play a lot of things safer and not push the boundaries as much, which basically hampered the entire program. One other reason why they didn't do it is because with the Challenger disaster, they had to restart the Titan line, Delta line, and all that stuff. So the non-reusable rockets, the non-crewed rockets, got restarted. It was supposed to be that all the payloads would go into the shuttle, but then they decided, well, especially the military decided that, well, if the shuttle's got to be having a downtime to fix its problems, it took 2 years, more than 2 years, to come back from the Challenger disaster, then they need the other rockets to be able to do things. And if the shuttle was able to carry the Centaur stage, that would limit the utility of the other rockets, especially the Titan rocket, to some extent the Atlas rocket as well. But the Titan rocket, it was sort of expensive. Its production line wasn't super. It wasn't really commercially viable. They tried commercial Titan 3, but that didn't work great. So it was mostly military or government payloads, and it really needed to have the Centaur be its special thing in order for it to be viable for those. Otherwise, the shuttle was actually somewhat competitive with it, amazing as that might be. So removing the Centaur as a possible stage that the shuttle would carry is one thing. If you want an alternate universe thing, just let the shuttle carry Centaur and launch high energy payloads to places. The shuttle instead was limited to a set of two SRBs, the inertial upper stage. And so those two SRBs were its upper stage. And, it worked out fine for a lot of payloads, but it limited the shuttle's capability to launch payloads to highly energetic orbits, or its payload capacity to the moon or beyond. So that is the situation, and we are going to fix that. Well, the Centaur stage might have been risky, but what if we had developed ion engines early, and instead we had all sorts of pulsed inductive thrusters in this case, in order to let the shuttle do high energy orbits. And so here we have an argon gas tank and some ion thrusters. These are from near future, and they're configured just with the regular realism overhaul configurations, except I've added Pekka's warp thrust module to it, and so that we can actually do the burns during time warp. So these are real pulse inductive thrusters as far as I know. They are configured by Realism Overhaul. These are not the upscaled versions that I've made. I have those upscaled versions, but since we're using solar panels, I can't use those upscaled versions because those are meant to use nuclear reactors, and we're surely not going to put those on the space shuttle. This is meant to be safer than the Centaur stage because this tank is full of argon gas, which is inert. And so this whole setup is actually even safer than having the inertial upper stages. And we have the ion thrusters. They're not the most efficient. 2,500 seconds of ISP is not great, but the trade-off is that they get a lot more thrust. Pulse inductive thrusters, the way they work, you just increase the pulse rate in order to increase the thrust. And so we have the increased pulse rate, and these will get... It's still not great. It's still got to take forever, and we'll need to see if it can push this 14-ton payload. I underutilized it, so it's taking up some volume. And right now it's just carrying avgas. It's a test payload. And we also have MH and MON3 as our RCS thruster propellant here because we need that. We don't have any way to do RCS with the argon gas here. We ought to, but I'm just going to leave it be like this. Otherwise, it's going to be too frustrating. So we are carrying a fair amount of MH and MON3, 2 tons. We could probably cut down on that. But for now, this is the situation. And we are going to see whether it can push this 14 tons all the way out to the moon and maybe be reusable. That's why I put docking ports here. But you can see it takes up the whole bay. You can't put docking ports, the normal airlock assembly in, which is why we're using Columbia. I don't think it was ever fitted with that. So we are going to launch this and then proceed to test the ion assembly as it is right now. So this is improvement on the capabilities of the shuttle without actually modifying the shuttle, because then it will be able to do missions to far-flung places and carry a decent payload to them. Alright, so we're not going to line up with the moon or anything because of the way the ion engines work. We're going to get there when we get there anyway. So, OPS 1. Well, we can go like this. And off we go. So my intention with this is not for... I have plenty of plans for just about everything, including the space shuttle. I just don't have enough time to do everything. So one plan is to build a station around the moon using this sort of setup with the ion engines. It's basically like Lunar Gateway except built with the shuttle and more complicated than Lunar Gateway. 14 tons is heavier than a normal Lunar Gateway module after all. Alright, booster set. Finally decided to not use the separation motors that were on the model and instead add my own separation motors so that those could move off cleanly. Volumetric clouds looking good as we coast along, though They are probably causing my poor little GPU to work extra hard, and if you hear some rumbling in the background, that'll be what that is. The GPU struggling with the volumetric clouds. But for now, that's drowned out by the engine sound. Alright. Separation of the external tank. Since we have the fuel, we might as well get to a somewhat higher orbit first, give it a better start. So it's going to have to cycle out, its thrust is too low otherwise. You really do want to use the largest possible panels, and in this case tweak scaled up, because if you use multiple panels, then you're not actually getting as much area because it doesn't really scale up in length as much. Alright, that still leaves plenty of fuel to come back down. Undock. Move away. And let's see what we can do with this. 8 of these thrusters at the bottom. The Farad pulsed inductive thrusters. Okay, well, we need to switch to SAS for this to work. And let me turn off RCS. So it is changing our orbit. I'm gonna say hold prograde and time warp. Okay, it is changing our orbit. But this is not the best orientation for electric charge, so hold on. And we of course won't be getting any thrust on the nighttime side. I don't think we can run all the thrusters at full thrust with this panel, these panels. So that is a problem, but are they not firing? Well, we've got power. Flame out. Okay, maybe... Oh, that one doesn't have any electric charge. Let's see. I'm wondering why it's deciding to flame out. Okay, well, let me try and sidestep that by currently using all engines. So now the plugin is using them, but yeah, we're not generating enough power, but it's using, providing as much thrust as it can given the power that we've got. Here it's generating enough power. So alright, we're going to very, very slowly lift up our orbit and see when we actually get to the moon. Obviously, this would not be good for anything crewed. For something crewed, we would want to use Centaur. It throttled down on the nighttime side, but it doesn't throttle up again when we go here. I think the KSP Interstellar one actually would throttle up again. And we're not going up very quickly. If you're wondering about our delta V though, 7,738 meters per second. With one, it's 3-year burn time to do that. Obviously, this tank was made long so that it could accommodate the solar panels. That's why it's such a long tank. Well, I'm just going to shut them off and let the plugin handle it, but I don't know if I have enough patience for this. Oh, but then we have to deal with the shuttle having limited supplies. Right now, it really should have the oxygen generator on. Let me come up with a different ion engine solution than the near future ones. I think I'm gonna have to resort to the KSP Interstellar ones so that they'll work on they'll pick up the thrust after passing the nighttime side instead of resetting and having me come out of time warp. So this is actually a Lackluster Labs part that I modified for KSP Interstellar, and hopefully it'll work a little bit better. We're using xenon gas with it, and so this is now a xenon gas tank. Downside is it's heavier than the others by quite a lot, but it's also more efficient. It gets 2,800 seconds of ISP, so maybe it'll work out for us. It's based on the X3 ion thrusters. So I don't know if this. I've had to reduce the size of the solar panels. Might be okay, just barely. We can see this requires zero point 0.1 megawatts, and we have two panels that at Apoapsis get 50 kilowatts each. So it's just barely if everything works out. But anyway, we'll try this version. But so far, my experimentation with ion engines, well, it's a little bit fraught. Let's see if this works. And off go the boosters. Okay, we are about to make orbit with the OMS burn. Okay, let me get to the daylight side and then we'll start operations. Out it goes. So, how much delta V? 8,539, in this case in 3 days, because Xenon is more powerful, not more powerful, has more thrust than the argon gas ones. In configuring this one, I just used whatever was existing in KSP Interstellar and based it off of the X3 thrusters, so. Yeah, in this case, it doesn't provide any benefit to our orbit at nighttime, but it still has the throttle up, so I don't have to constantly reset it. So that's why we're using this version. And this possibly a product of it using the megajoules to measure things. Okay, so we cycle, make a bigger orbit. I think we should be done because of the burn time it's saying right here. And maybe it would be 30 days, really. But let me just switch over to Columbia, and we're going to turn on the oxygen generation. I think we'll get to the moon before it needs to come down. But yeah, I might review the thrust of this and knock it down by a factor of 10. I think I might have given it a factor of 10 benefit so that it was more reusable, but it might be overthrust. I'll double check that. But delta V wise, it doesn't make a difference. We would still be cycling out. It just takes longer. But as long as we can do that with this with the delta V that we've got, it'll functionally be the same thing. Again, we're not got to put crew on it. Oxygen again? Maybe it's just not keeping track of the oxygen generation. Okay, I've cleared the shuttle away, and we are now just focusing on the ion unit, continuing to cycle up towards the moon, and we'll meet the moon either at the ascending or descending node, because obviously we did not line up with it. It's not necessary to do so with this because of the time it takes to actually get to it. Well, that's a lot of encounters. I don't want one in 100 days. That's the one I want. Well, let's set that up first. Okay, that seems a minimum. Let's just go over there. That burn would have been quite possible even with a lower thrust model, but this one we would probably have to do something outside of the SOI first. Maybe, maybe not. Capturing is not too bad. Okay, getting closer. And that's probably close enough. We can't do the capture burn instantaneously, but I have some experience with how to deal with that. And we just need to point straight up away from the surface. It'll be fine. And there's a capture. Well before periapsis, I could have waited longer. Okay. And then we could bring it down further. I want to see how much delta V we have left in here if we just let it go now. So that's a 14-ton payload to the moon. And on here, not enough to get back really, even if we're very careful with it. But so with a lesser payload, we could probably make this reusable. Or if we want to just expend it, we could carry a heavier payload than we did just this time. So that's possible too. It would probably have taken longer. This was 19 days, but that was mainly because of the final transit. Most of the burn time was 3 days. So what we should do is we should take the 3 days out of it, let's say 16 extra days, and then add it to 10 times the burn time that we had here. So 30 days plus 16 days, more like a 46-day travel time with the payload is what I think we should be having here. So anyway, that is the situation. Now, what can we do with it is the question. So this is the shuttle with an ion stage. It is a very peculiar sort of stage because it's this long tank, but that's to accommodate the solar panels because we can't use nuclear reactors, which I really would like to use, but we can't on the shuttle. So we will do it this way. And we can carry a substantial payload to the moon, getting it into orbit. I mean, it's not as much as Saturn V can get to the moon, but this is good too. The xenon gas is a little bit expensive and also hard to come by, but we're not using that much here. I think we're carrying maybe 8 tons, 9 tons-ish, so it's not too bad. Many other considerations could be mentioned, but I think I've covered enough for now. So that's the idea, and we could put that to use with the shuttle. But with crew, I would still use probably something on Centaur, and we can see that in some subsequent video. So there are shuttle plans. I'll get to do shuttle things, and I'll bring them to you as soon as I can. So with that, thank you for watching. I hope you enjoyed this video. If you did, please do press like. If you have any comments or suggestions, please leave them in the comment section below, and I'll see you next time.